So in this video, we're going to be setting up our enemy. Now, if you happen to have skipped the last video where we demonstrated how to set up a template inside of Visual Studio, I just want to point out real quick that we wrapped the video up with the creation of the enemy script. So we already have it, just in case somebody skipped over the video.
Well, it's based on the template we put together.
That's right. And you'll see down here in scripts, of course, we have enemy. Now, let's go ahead and create our game object. So we're just going to, again, following Mr. Jones's example, we're just going to use a simple sphere. And again, we could say that this is stand-in geometry that later on we could easily swap out for our own model. So we're going to come up here to game object and come down to create other. From there we can jump down to sphere. Number one thing we need to do, make sure that we rename them. So rename him enemy. Next thing, I'm going to go ahead and just center him in the world. And then for our scale, let's make him just a little bit larger. So we'll go with something like 1.3. Okay, that looks good. Next thing I'd like to do is set up a material that we can apply to him. So I'm going to come down here to materials. I'm going to right click, come down to create material. Let's go ahead and give this guy a name. Following our convention, it'll be m_enemy, like such. And for a color, I don't know. What do you think, Zach? We'll go with red.
Red generally means bad.
That generally means bad, absolutely. So we'll go with red. So now we have a color. Now let's go ahead and grab this and apply our enemy material to our enemy. Okay, so as you can see, everything's been applied, looking good. The next thing I'm going to be interested in is going to be his position, getting it all set up and then getting him in motion. Now he is going to be moving in the y-axis downward, and we would like for him to move from, random locations as he's moving down. So we're going to keep the AI simple. Actually, there is no AI. We're just going to pick a random location across the top, right out of the screen, and then we're simply going to let him move down. If he collides into the player, the player is going to die. If a projectile collides into him, then he's going to die. If he manages to make it off the screen, we're simply going to jump him back to the top.
If that happens, are you still going to spawn another enemy?
Well, that's just it. We're doing this in the cheapest way imaginable.
So you're not actually.
We're not really destroying him.
I gotcha.
In this case, when we say destroy, what that really means is quickly move him back to the top of the screen off the top, pick a new random location, a new random speed, and let him go down again.
Gotcha. So there really aren't multiple enemies. There's just going to be this one.
There's just one. Though you could set up a prefab. You could create an empty game object called an enemy spawner and then attach a script to that. And then in that script, you could instantiate these game objects, and you could have that guy responsible for what level are we on, or reading the level that we're on and determining how many enemies that we want to spawn over a certain amount of time. So it could say that, all right, we've made it up to level 20 and we want to spawn an enemy every 2 seconds, which means our screen would then be very populated with enemies all over the place. There's so many things you can do with Unity. It's very neat. But we're just going to work with just this one guy, no destruction.
Okay.
So with him, to do all of this stuff, of course, we're going to need to be working inside of our script. So let's jump over into the Visual Studio, into our script for enemy. And I'm going to start out by creating a couple of public fields for the enemy that we can use to set up a speed. I don't want this guy just to have a steady speed every single time he's coming down. I think it would be a bit more interesting if we gave him a random speed every time.
So some enemies move faster than others.
Exactly. So if we wanted to, we could come up here into fields and start out by saying I want a public float, and we'll say that this is going to be a min speed, and then another public float, and this will be our max speed. We can hit save. If we jump back over here, it automatically compiles, and we have access to that information. So with enemy, we need, of course, to make sure that our script object has been applied to our game object. So we'll come down here and grab enemy, drag him up, drop, and then there we are with our minimum speed and a maximum speed. So if we go with, I don't know, 4 to 6, and we can come in here and adjust that as we need. Let's jump back over. Now, what are we going to do with this speed? Well, we need to generate a current speed, if you will. So we'll grab a number within this range that we have defined, and then we need to hold that so the enemy can be using that speed as he travels down the screen. Then when he gets reset, he can generate a new random number and store that.
Right.
And the way that I'm going to do that is I'm going to set up another field. This guy, we can just keep him hidden. We can have a private float, and we can call this current speed, like such. Now, let's see. We'll just, all right, I'm trying to decide exactly how I want to go about this. Let's just stick with the speed stuff for now. So now that we have a minimum speed, a maximum speed, and a place to store a current speed, we need to generate a current speed. A great place to kick things off would be inside of our start function. We know that start gets fired one time, and that one time is right before the first update is hit inside this script object. So what I'm going to do is just come down here into start, and I'm going to say our current speed is going to be equal to. Now, we have a random object that we can use with Unity, which is very nice. So if I come in here and say, let's use a random, with random I can say a random range, and then the random range is going to take in a minimum and a maximum, and we have a min speed and a max speed.
Right, let's use our public variables.
You got it. So we can set those numbers over in our inspector, and then those number values are being respected inside our start function to randomly generate between those numbers a current speed. So now we have set up that speed. The next thing we need to do is apply that speed to our enemy. And we're going to do that inside of what function, Zach?
Our update.
In our update, absolutely. So we'll come down here to update. And I'm going to follow the same convention that we have used so far for both the player and projectile, and that is to create a local variable, so float amount to move. And amount to move is going to be equal to, we're going to do our current speed times, since we need to make sure that we have this a consistent amount that's moved per second, so we just times it by, or multiply it by time.delta time. Okay, so now that we have that set up, we'll just turn around and use it by saying take the transform dot translate, and then instead of going up as the projectile did, we're now going down.
So you got negative y.
So in this particular case, all I need to do is a vector 3 dot down, and then I'm going to multiply that by our amount to move, like such. So if we save that and jump back over into Unity and run this. Oh, and lovely, hang on. Let's set that back up again. Now when we run this, he is going to move down the screen. So let's hit play.
There you go.
And he's moving down the screen. And let's do this for just a few minutes. Let's take current speed. Let's make it public to make it show up over in the inspector, so we can see it, and we can basically prove to ourselves that we are indeed coming up with a random number between the range that we've given.
Right.
So public, though this is a case where this is a number that does not need to be accessed externally, and we would keep this private. So let's save this off and run again. So there we are. Current speed is at 0. When I hit play, 4.6. Let's stop it, play again. 4.8. Come on, give us something higher. 5.4, and we got something higher. Excellent.
Nice.
Very simple. Now, for our enemy, we want him to start off screen, so he's going to need to be up here somewhere. So we could say perhaps maybe around 7. And then when he goes off screen, so if I was to take and move him over a little bit, when he goes off screen, I need for him to reset back up. There's a few things that we need to do. So for starters, just leave them right here. Let's set the code up just so that in start is going to position him off the screen in Y, and using what we've already seen with random range, let's go ahead and come up with a random location horizontally between here and over here. So that's going to be between what, about -6 and +6. Looking up there at, look at that. So position minus 5.9. Yeah, so -6, +6. So let's jump back over here. And again, using what we have seen so far, I'm going to come up under our current speed, and I'm going to create another field. This one will also be private. Now, let's always, at the moment, pretend that current speed is indeed private.
Sure.
So this guy is going to be a float, and I'm just going to set up an X, a Y, and a Z. Now what I'd like to do is jump down into Start, and in Start, we know what we would like Y to be. Y needs to be 7, as we demonstrated back over there. And I know I could just simply use a vector 3 with just an X and a Y. Let's just go ahead and spell everything out.
Okay.
Like I said earlier, keep it black and white. So we'll set Z as 0.0, so he's at 0. So X is the interesting one. We saw that X could be anywhere between a -6 and a +6, and we've already seen how we can go about using random. So let's just simply come in here and say X is going to be equal to random dot random range, and then we can say -6 and a +6, like such.
And you're specifying those as floats.
And we're specifying these as floats. I'm typing F's all over the place. Didn't have to do it here, but it's good practice anyways.
Yeah.
All right, so this will get him positioned properly, even though we know right now the starting location has him down here at the bottom. Am I right?
Well, it should be, because you've got it set up to where as soon as start takes place, he's going to be moved off screen, and then it's going to pick a random horizontal location. Or, well, most of the way. We haven't actually set up the transform for that yet.
Ah.
We've established 3 variables.
We've got 3 variables.
Yeah. So we've got the framework down. We just need to set up that initial transform.
So we need to somehow use this information. I almost got you to fall for it.
Almost.
All right, so how are we going to use the information?
We're going to do transform.position.
Okay, so we know that transform.position would definitely allow us to, position the guy. So let's just jump up underneath this and say, let's move him. Transform.position is going to be equal to a
new vector 3.
Very good. And then X,
Y, and Z. The 3 variables you set up.
Yep, we've set them up. We just
Now,
never used them.
Just for proof of concept, granted, if everything works right, we should be able to see that ball pop up in a new horizontal location. Do you want to make that private variable public just so you can see the number while we're testing?
In this case, we will see it just by the fact that he's going to
Yeah.
move around. So that one we don't have to.
Okay.
Let's see that he does indeed move. So hit play, and look at that. He's right there. Okay, same location.
There's a new
Different location. Another location.
Nice.
And every time he's starting off the screen, scrolling on to the screen.
Actually, at this point, you could probably take that variable that you made public and go ahead and make it private again. Because we've already established that it's working.
So let's do that. So we'll come back up here. When we get into the advanced topics in a later video set that's redoing this game, you'll have to listen to me talk about nothing is public. Everything is always private. So very important. We don't want to destroy the idea of object orientation and data encapsulation. So moving on. So now we've got these guys set up. We're using them. The next thing that we need to do, as we said a few minutes ago, was monitor his Y position in space, and the moment he goes off the screen, make sure he resets back to the top. So in order to do that, let's first just jump back here. Since at the moment we're not doing anything fancy to determine what our screen bounds are, and let's just do this by hand. So again, we're traveling in Y, and as he's moving down, 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 and goes right off the screen, I'm looking over here, and I'm seeing a -5.3, so I think we can get away with, we can get away with -5. So when he is less than or equal to -5, then we want to make sure that we jump him back up. So in update, after we've moved him, then we want to do an if statement. So I'm going to say if our transform.position.y is less than or equal to
-5.
a -5. If that is indeed the case, let's go ahead and block this in. What do I want to do? Well, I want to generate a new current speed. I need to generate a new X. I do not need to generate a new Y and a new Z. Remember, these guys are fields, so their state has been set. So I don't need to set them up again, but the current speed and X, those two guys do change. So I can just grab these two guys, copy, come all the way down here and paste. There we go. Now, once again, we need to make sure that we use this. So we just grab this guy right here and position him. And let's save, and let's look at the code. So every single frame we're coming through, we're grabbing an amount to move based off of a current speed, which stays consistent until, so this value does not change until we hit a state in which we are being reset back to the top. Okay, so we come in here and we get that. We move our guy down. After the guy's been moved down for the frame, we then check his Y position. If it's less than or equal to -5, we're going to generate a new current speed between whatever has been set as min and max over in our inspector. Then we're going to turn around and we're going to grab a new random range between -6 and +6, and then we assign the position. Now, just in case anyone out there is a little bit confused and says, wait, but how do you make him jump back up to the top? I mean, because his Y's got to go back up. We never did anything with Y. Y is just holding a value for us. It's 7, and we are reusing that 7 right here. So that's going to cause him to jump back up.
It's still being stored. We haven't changed it.
Absolutely. So with this bit of logic set up, let's hit save, jump back over, and let's go ahead and execute. So he's going down, and he's reset.
Nice.
And now he's just jumping all around. And the nice thing is, while we're playing, we can say, let's try maybe speeds of 6 to 20. So, whoa, nice, a little bit slower. Whoa, a little bit slower.
So really some will be really fast.
So now we can really see the whole random thing kicking in. And if we wanted to, we could store a level. We could say, you know, every X number of ships.
Speed things up a little bit.
We could, or how about this? Even if we didn't do a level, here's a very simple thing that we could implement. Every single ship that gets destroyed, as soon as it gets destroyed through code, make your min speed and max speed both go up by like 0.2.
Yeah.
So as you're hitting more and more, he's getting faster and faster and faster.
Right.
So the game becomes more difficult. Maybe we'll do that later. Very simple stuff. Now, keep in mind, I have made these adjustments while the game was playing, which means the moment I stop the game, it will revert back to what it was before we hit play. That's all we needed to do for this particular video. Now, I'll be honest with you. I have something going on right here that I'm not a big fan of.
Well, it seems like the establishment of your speed and your position could all be put inside of a single function.
Absolutely. We've got some repetitive code in here and the code needs to stay the same. So a little bit of code up here and this code right here, and then we have the same code down here. So this could be centralized. In the next video, we'll take just a few minutes and we'll talk about that. So with that, that is going to wrap this video up. Thanks a lot.